Well, welcome everyone to today's webinar on structural equation modeling. A couple things I want to point out is we are lucky enough to have Laura Castro-Shiloh joining us. She's actually the R&D scientist who leads the development of our SEM platform. So she'll be participating today and helping answer questions. There's a poll on the screen right now which is asking which software you use. When we were just chatting about this a few minutes ago, we thought of two other questions that we don't have a poll for. So if you could kindly type this in the chat, um, can you tell us what software you use for SEM? So if you are currently doing structural equation modeling, can you point out which software you are using that in? And then the other question that we have, and this would be great if you could type this in as well, is could you tell us what discipline you're coming from? Are you coming from the social sciences? Are you coming from the natural sciences or engineering, physical sciences? So if you could go into the chat window and tell us two things, what your discipline is, and also which software you're currently using for SEM, that would be great. Now there's a chat window, which is where it'd be great for you to type in. Oh, now I see everybody going into the Q&A. If you have a question, type that in the Q&A window, not the chat window, because it'll be easier for us to monitor the questions that way. But if you have just a general comment, or basically what I'm asking now is your discipline and what SEM software you're using, you can put that in the chat window. So with that, let me check in. Ross, do you feel you're ready to go?
Yes, I am. Thanks, Kevin. And everyone, I see somebody just mentioned that the chat has been disabled in Zoom. So sorry about that. I did not intend for that to be the case. So go ahead and just put that stuff in the Q&A instead, since everybody already has. Much appreciated for those of you who already have answered those questions in the Q&A. And Kevin, if you could just go ahead and dismiss those, we'll be able to just take a look later. All right, but anyways, let's get started talking about structural equation modeling. And again, this is part of our summer academic webinar series aimed specifically at academic researchers. So we're going to start out assuming little to no knowledge of structural equation modeling and hopefully get you on your feet today. Before we do, though, I want to point out that structural equation modeling, it's a large, robust modeling framework that combines linear regression modeling and factor analysis. And you can use it to do a lot of different things. I have a diagrammatic representation here on the screen of the primary features or capabilities with respect to SEM in the JMP Student Edition. And also, if you're a commercial user and can't use the Student Edition, also in JMP Pro. And there's even more to structural equation modeling than the simple kind of 6 groups I've put things in here today. So obviously we can't possibly cover all of this in an hour. As the title suggested, we're really going to be talking about path analysis and structural regression. And then a component of that is a collection of techniques known as mediation and moderation analysis. And so again, my goal here is to introduce you to these techniques, some of the conceptual foundations for them, and also how to implement them in JMP so that then you would be better or well prepared to maybe continue with further study on your own, or even be able to dive into some data you have and start doing some of the basics. And even though we're zooming in here, I also want to say that this really is, it's a large topic, potential for a lot of detail. I'm sure some of it will come up in the Q&A. I'm going to try to stay pretty high level and focused so that we don't get overwhelmed here today. We're going to center our discussion around a single example today so that we don't have to spend, the cognitive bandwidth or cognitive load on jumping between different examples. And the example here is from an HR or human resources context. So imagine that we want to know how leadership, that is managers in the workplace, and conflict in that workplace influence job satisfaction. And conflict here doesn't necessarily just mean interpersonal conflict. It could, for example, mean conflict between what you are asked to do and what you believe should actually be done in your job. Now, there are a variety of ways you can approach this question, but us, especially as academic researchers, we're typically focused in theory development. And so we might have multiple theories about how leadership and conflict influence job satisfaction. So theory number 1 might look, if we were to create a diagram, something like this. both leadership and conflict influence job satisfaction. I am making essentially a causal claim here, but they don't influence one another. They're not related to one another in any way. So I might collect data, and we're going to be looking at survey data today, to test this theory to see how well it holds up or how well it can account for data on how people report their perceptions of leadership and conflict and job satisfaction. Now, how could I actually get an answer? That is, how could I assess if that theory is appropriate? Well, in this case, I could probably use just multiple regression, right? Essentially, I have two effects, one of leadership and one of conflict on our outcome variable job satisfaction. And so I could just do a simple regression where satisfaction is equal to some intercept plus some slope times your leadership measure plus some other slope times your conflict measure. So this is all very standard stuff that we're probably all very familiar with here. But this is also a overly simplistic theory, you could imagine. You might propose a more realistic theory that could look something like this, where we say leadership probably affects job satisfaction, so better leadership leads to higher job satisfaction. But leadership also actually influences conflict. So maybe better leadership reduces conflict in the workplace, and conflict probably influences job satisfaction. So maybe as conflict goes down, job satisfaction would go up. So this is a more complex theory, and note that multiple regression would not give us a great answer here, or maybe not even be able to. And that's because in this particular theory, conflict is both predicting job satisfaction and being predicted by leadership. So we have a particular variable playing multiple roles and maybe a theory about how these variables are causing changes in one another. In multiple regression, you can't just create some simple equation to handle that. But structural equation modeling, in particular path modeling and structural regression, can handle this situation. In this simple example, what we would really have is two different equations. One where conflict is being predicted by leadership, and another where satisfaction is being predicted by both leadership and conflict. This theory might correspond more closely with reality, and in being able to fit a model that involves multiple equations like this all being estimated simultaneously can actually tell us about how leadership influences job satisfaction directly and is, as we'll say throughout, mediated through conflict as well. So this is just a quick primer on where structural equation modeling comes in when we're talking about testing theories about relationships between variables. And that's what path analysis and structural regression really is good for. Now, these theories, I just showed some simple diagrams, and they really are typically expressed in diagrams or what are called path diagrams. And we see a slightly more complex path diagram. This is actually straight out of JMP. We see that on the left here. So we can see we have leadership, conflict, and satisfaction displayed. I'm saying that we have a direct effect of leadership on satisfaction. I'm also saying that we have an indirect effect whereby leadership affects conflict and conflict affects satisfaction. You'll also notice some other things here. So for example, conflict has these three other things connected to it, where it says person C, intra C, and inter C. These actually represent the survey questions we might ask somebody about different forms of conflict that they experience in the workplace. For example, person C is that one I mentioned before, where it's a perception about how what somebody's asked to do conflicts with the way they think things should be done. So in path analysis and structural regression, we have the ability to test complex theories about interrelationships between variables, and all of the rest of today is going to be talking about how we do that. But a few things to note right off the bat. In this framework, you can model both observed variables, or what we might call manifest variables, and also unobserved variables, or what you might refer to as latent variables. So in this diagram we have over here, what it's telling us is that we actually have several different measures of something like conflict or leadership or satisfaction. We're using those to infer some general unobserved variable, that is leadership more holistically, conflict more holistically, same for satisfaction. And we're able to actually build and test theories about these latent or unobserved variables. We're actually going to start out with just working purely with observed variables. In this particular model that we're looking at, we're going to work our way up to being able to build it and explore it and see both how well it actually fits our data and what we can learn from it. As I already have established, another big benefit of path analysis and structural regression is that a single variable can both predict and be predicted by other variables. So again, that's conflict in this case. This allows structural equation models, path models, structural regression to better approximate the real world, where it's often not the case that a single variable is only causing one other variable. Oftentimes, they might play a causal role in one place, but be caused by other things. And so we can accommodate that in this framework. And then finally, we're going to see this towards the end. We might have multiple theories that are justified, maybe a priori, by what we know about a particular domain. And we might want to test multiple theories against one another. And you can do that as well in path analysis and structural regression. So we're going to work our way up to building this particular model that you see on the left. And we're going to compare it to another slightly simpler model to see which one actually better accounts for the data that we've observed. So that's just a quick bit on what path analysis and structural regression is and where we're going to go. Now, again, this is kind of our end point today. So we're going to build up to something a little simpler. Before we do and show you that path diagram, I want to just unpack these path diagrams a little bit more and point your attention to the 4 basic components or elements of these path diagrams. And this is both in JMP and what you'll encounter just in general. So you'll notice that variables in these diagrams are denoted by either rectangles or circles. The rectangles are for observed variables. So again, all of these are representing survey questions that people actually responded to on varying numerical scales. Latent variables, so these are the unobserved variables that we infer from our observed variables, are in these circles right here. You'll notice arrows connecting things. Some of them are double-headed, like this one right here. These represent variances or covariances. So for example, this one just represents the variance in this unobserved leadership variable. If it were to be connected, let's say a double-headed arrow like this to another variable, that would represent the covariance between them. In this particular model, we don't actually need that. You can see we have a single-headed arrow connecting leadership to conflict, and that signifies a regression in this case. So literally the effect of leadership on conflict, what a change in one unit of leadership will produce as far as a change in conflict. Now, when you have the arrows leading away from these circles to the rectangles, so from latent to observed variables, these are loadings. We're going to use some terminology from factor analysis today, where factor analysis is all about inferring some kind of unobserved variable from observed variables. I'm not going to get into the details of how all that works, but if you're familiar with factor analysis, just know that these actually represent the loadings. And we're going to talk about these loadings and interpreting them in just a little bit. But that's how you can unpack these path diagrams. And it's actually important to know, not just for looking at these, but also building out your models, because the models are specified or can be specified by actually just building a path diagram that corresponds to your theory. So we're going to start looking at a path model specifically for mediation analysis. So I've already established this particular example at the outset where we have leadership, again, having a direct effect on satisfaction, but also that indirect effect through conflict. You'll notice where we're starting here, we have only rectangles. So I'm talking only about observed variables. So LEA ... average there, what that's telling us is that's just an average across all of the leadership questions asked in a survey, and then similar for conflict and for satisfaction. So we have the path diagram specifying a particular model. Now we have the more plain English interpretation here, which is just saying the effect of leadership on satisfaction is mediated by conflict. I put up some equations at the beginning that specify this model more formally, but let's review them a little bit more to start to understand how these models work. So first, we have a regression of conflict on leadership. So the equation for any given conflict measure might look like this. So the conflict for the ith individual is equal to some intercept plus the effect of leadership quantified by this parameter, this beta, that actually corresponds in our path diagram to this value here. So a negative value, meaning as the leadership goes up, conflict goes down, plus some error. And the variance there is actually captured in this case right here. Now we have a second regression, which is satisfaction against both leadership and conflict. So again, we have satisfaction equal to some intercept plus the effect of leadership. Now this is the direct effect right down here, plus the effect of conflict. So that would correspond to this one right here. And so you can see a positive effect of leadership. So as leadership goes up or improves, satisfaction improves. A negative effect of conflict. So as conflict goes up, satisfaction goes down. And then we also have, again, some residual error in the variance here quantified right there by that double-headed arrow. Now you'll also notice we actually have right here a variance of leadership itself. We're modeling that and the mean of leadership using this third equation right here. So this is the model that we've fit, or that we're about to fit, I should say, in JMP. And we're going to be looking throughout at some parameter estimate tables. So here's an example of the output that we're about to produce. I've actually simplified it so all we're seeing are the estimates without any statistical tests. We're about to see the full output in a moment. But again, just to try to help you map from path diagram to the equations to the tables that we're actually going to interpret. Again, we have 3 different means or intercepts right here, denoted by these taus. Those can be found right here under the means and intercepts portion of our parameter estimates. They are not displayed by default in the path diagram, just to try to keep things clean. But for example, if we wanted to know what the intercept is for satisfaction, we could just find it right here, 3.71 approximately. Now, we have 3 different regression slopes. We have one here, here, and here. And so we have 3 different regression slopes estimated right here. So let's say, for example, we wanted to see the effect of leadership on satisfaction. That's this value right here. Well, we can find that in our table right here and right here in our path diagram. So all of these correspond to each other. And then similarly for the variances, we have 3 variances, 1, 2, 3. 3 variances listed here, 3 variances in our path diagram. But you're going to notice, and this is a particularly useful part of this whole modeling framework, is that you can also model what are known as indirect and total effects of our predictors here. So let me unpack that a little bit. We've said that leadership affects satisfaction directly, but it also reduces conflict, and reducing conflict can increase satisfaction. This effect of leadership is known as an indirect effect, and you'll see it in the table right here as 0.206. So where does that value come from? Well, actually, you just take, oops, wrong thing right there. Let's get our box there. You trace the path and multiply the coefficients along it. So negative 0.587 times negative 0.351, that'll actually produce for you this indirect effect. So we're saying as leadership goes up by 1 point, we expect satisfaction as mediated through conflict to go up by 0.21 points approximately. And then we have the total effects. So we have leadership being able to affect satisfaction 2 different ways here, the direct and indirect path. And if you want the total effect, you can just find it in the table right here. So the leadership effect on satisfaction, a total of 0.63. Now, you'll be getting a link to the recordings and the slides. I've included the actual equations here for you to consult. So the indirect effects, again, you just take the product of the regression coefficients along your path from your predictor to your outcome. And the total effect is actually just the sum of the indirect effect and the direct effect. So take the indirect effect right here, plus the direct effect, which we actually found back up here, and you will get your total effect, 0.673 down here. And so this is actually really useful. I want to, this isn't just a point of showing you how to map, numbers from a table back onto your path diagram. this actually tells us something really important. If we were to, and we'll do this really briefly, if we were to regress satisfaction against leadership and just ignore conflict, you would get this value right here. That's what it would look like to us. But what we're saying with this particular model is theoretically, some of the effect of leadership is due to a direct effect, but some is due to the fact that conflict goes down when leadership goes up. Now, imagine you're actually at a particular business and you are thinking about instituting some new policy changes that might actually affect this path right here. So maybe we're going to put some restrictions on some of the decision-making ability of low-level managers such that they're not going to be able to most effectively reduce this form of conflict that was causing this particular relationship. We would actually then know that eliminating that path will actually make the overall effect of leadership on satisfaction less. So if you just ignore this path completely, you might think, oh, well, if I mess with this, the effect of leadership on satisfaction is still going to be 0.67, but really it's going to drop down to 0.467. So being able to properly specify these theories and try to establish the effects through direct and indirect paths can actually lead to a more robust understanding of the system that you're studying so that you can actually make better decisions about how to maybe change or improve that system. Just one example here of why these models really are kind of useful at a theoretical level. But anyway, that's enough of a big primer. Now I want to get into JMP and actually show you how to do some of this stuff. So let's move on over to JMP. Here I have our job satisfaction data open. So this is, again, a job satisfaction survey. We have 200 individuals measured. You can see that in the row count down here in our table. We measured leadership through 4 items. So there are 4 items right here, 3 items for conflict, 4 items for job satisfaction. I will point out, you'll be getting a link to download this table. It's actually bundled in JMP itself. You can hover over any one of these column headers to find out what the item was that somebody was responding to. So this one, my supervisor is friendly and easy to approach. So that was support_L. And you can see values in their rating scale ranging from 2 to 9 on a 10-point scale. Now, one thing that's nice about doing structural equation modeling in JMP is that it doesn't just do structural equation modeling. If I were starting out with these data, I'd probably want to just start exploring them graphically to get an idea of what kinds of correlations there are among variables. So really quickly here, I'm going to go into our multivariate methods menu where you'd find our structural equation modeling platform as well as some others. And I'm going to choose multivariate. I'm going to grab all of our survey items, put them in the Y columns roll, and click OK. And actually, let's see, I'm going to use a platform preset. So if you're not familiar with platform presets, they allow you to very easily switch views inside of a JMP window by basically making many red triangle menu selections all at once. I'm not going to show you how I did that, but go ahead and Google JMP platform presets if you're interested. So what we have here now is a scatter plot matrix with density ellipses and also a heat map on the correlations with the correlation values displayed here. And we can see some interesting patterns. For example, one that we'll explore a little bit later. We have negative correlations between all of these these four leadership measures, and then the 3 conflict measures. As we said before, and as we kind of saw in those parameter estimates that I've already shown you, as leadership goes up, it appears that conflict goes down, and we're actually seeing that in the raw data right here. But now let's actually get into the data. I should also mention too, and I'll call this out again, we are assuming in this case that the survey that we've used here is validated. That is, somebody has actually created and done the appropriate research to validate the instrument. So that's typically done using confirmatory factor analysis to determine the validity and reliability of your survey items. So valid meaning that they're measuring the thing that they're supposed to measure, and reliable meaning that they're not subject to an egregious amount of noise or being influenced by other things that you don't want them to be influenced by. But now, remember, we're starting out with a simple path analysis, no latent factors. What we're going to do is take the average of all of the leadership items and conflict items and satisfaction items and build this particular mediation model. Now I'll show you in this table, we already have these averages calculated. So if I go to leadership average and right click, I can look at the underlying formula, and it's just taking the mean of the 4 leadership items on our survey here. So let's actually build this model, get those parameter estimates, and learn a little bit about how the SEM platform in JMP works along the way. So I'm going to go to Analyze Multivariate Methods and choose Structural Equation Models. This gets us to the SEM launch dialog. So in this dialog, we select our variables of interest. In this case, it's just these 3, put them into the model variables role. You may have noticed at the outset that JMP's structural equation modeling platform can do multi-group analysis if you want to. You can put your grouping variable in right there. I'll also point out there's tabs at the top. So for summarized data format, that would be if instead of raw data, what you have is a covariance matrix. You can actually perform structural equation modeling directly on the covariance matrix. Just go ahead and select standardized data format to switch over to that view and input your data. But I'll click OK. And now what JMP produces is an interactive path diagram for me to specify my model. So I have in here my 3 variables. You'll notice double-headed arrows on each, meaning that each one already has a variance associated with it in the model. For all of you who are more familiar with structural equation modeling, you may also wonder if JMP represents the mean structure. It does. It's hidden by default, but I was able to reveal it with that right-click option right there. So again, that was right-click, show, and then you can go to show means and intercepts. Just to keep things clean, I like to leave that hidden. So by default, that's what you're going to get. Then you can use either the diagram itself or these lists to the left to build your model. So let's just first add the regression of satisfaction against leadership. What I would do is select leadership on the left in this from list. You'll notice it gets highlighted right here in my diagram to help me find it. I'll select satisfaction in my to list, and then I'll click the single-headed arrow to add a regression. And so here in my path diagram, I have just satisfaction regressed against leadership. You'll actually notice in this case, the arrow right here is rendering a little far away from the box. I've changed my font settings, which is actually causing that. So if you use default font settings, that doesn't happen. And also know that you can easily copy your diagram and paste as vector graphic if you're producing these for publication, and tweak these however you like. You can also just stick with the default font settings to eliminate that as well. I just increase them a little bit to try to help you all actually read the text well. All right, that's just a quick aside. Now, one other thing I want to point out here, again, just to help boost intuition for people who are new to this, is that all we've really done here is a simple linear regression, just as you might understand it from, say, an intro stat course. So when you've specified a model, I'm just going to preemptively run that model by clicking the Run button. And you get an output down below that includes the parameter estimate tables. And so right here, you'll notice leadership regressed against, or excuse me, satisfaction regressed against leadership. Our estimate is 0.673. So for every 1 point increase in our leadership scale, satisfaction should go up by 0.673 points. This is very much what you would get by just doing a simple linear regression. So now I'm in fit y by x. If I say satisfaction is my y, leadership is my x, click OK, and then request the fit line, you're going to notice the same parameter estimate. So there's that 0.6730094. It's the same as what we have right here. So for those of you who are brand new to this, and it's taken me a while, admittedly, to wrap my own head around structural equation modeling, we're not doing anything that you don't already understand, at least at basic level, as far as what we're seeing right now. Now, this isn't actually my model. I'm going to go to the red triangle next to this model name and go to Remove Fit to get back to just a bare specification window here. Okay, so I have leadership affecting satisfaction. I also said that leadership affects conflict. So I'll select leadership on the left, conflict on the right, click an arrow. And then we also said conflict affects satisfaction. So I'll add that as well. And now we have our complete path diagram specifying our model. A couple things I want to mention about this. First, if you prefer, you can click in the Lists tab to actually see a list of all of the different parameters in the model. So again, we have 3 means or intercepts being estimated. We have 3 regressions and we have 3 variances. The status tab is helpful. It actually lets you know whether your model can be identified or not. That is, whether you can actually estimate all the parameters of your model. And it has various identification rules. You'll see even more rules than what's listed here if you're using latent factors. But let's say I select the T rule here, it will tell me what that rule actually is. So this checks if there are more knowns than equations in the model. And it will tell me whether or not I pass and whether this is a necessary or sufficient condition for being able to identify the model. That is, again, estimate all those parameters. And we get a lot of additional statistical summaries down here about the model before we fit it. This is important just to make sure that we're actually able to estimate the model that we want. So that's the list and status tabs. Don't miss those. They provide very important information. Now also, just something about specifying your models via the diagram. I just use the lists to do that. There are other ways to do that as well. Let me click reset here. And let's say instead what I wanted to do was use the diagram itself. I could select, let's say, leadership and right click and then add a regression from leadership to something else. So I'm going to add a regression from leadership. I'm going to click satisfaction, and now that regression has been added. So it's pretty easy to specify our model this way as well. So let's get conflict to satisfaction. All right. So now I've specified the model solely within the interactive path diagram. There's yet another way. For some common model structures, you have these model shortcuts down here. So if I go to the model shortcuts, you'll find a number of handy-dandy shortcuts so that you don't have to manipulate the path diagram at all, including one for mediation analysis. And in this case, I can say my causal variable is leadership, my mediator is conflict, and my outcome is satisfaction, and click OK. And now we've built out our model structure that way. So 3 different ways, really just a lot of ways to get to building your model. Use whatever you think is easiest for your purpose. But now I'm going to give my model a name. It says mediation analysis. It filled that in automatically for me since I used the model shortcut, but I'm just going to delete analysis and call this my mediation model. And then I'll click run. So we get a lot of statistical outputs. You'll notice at the top, we have a model comparison with a bunch of additional statistics. I'm going to talk about this and then also this summary of fit. I'm going to talk about model fit towards the end. How do we determine what a good fitting model is? So for now, again, let's just focus on the parameter estimates. I already went over how to interpret these, but again, let's just, to help our memory, let's review. We have the means and intercepts that are being estimated. That's not displayed here. But again, you can always ask to see them by going to show means intercepts. We have the regressions, which correspond to these 3 values right here. So here we have leadership on conflict is negative. As leadership goes up by 1 point, conflict goes down by 0.587 points. We have conflict on satisfaction, also negative. So as conflict goes down by negative 0.351 points, or excuse me, goes down by 1 point, we expect satisfaction to go up by 0.351 points. And then leadership on satisfaction. That's the 0.467. So as leadership goes up, satisfaction goes up by 0.467 points. And we also have the variances of each of these variables as well. All of these are statistically significant. So we produced walled z-tests right here, and you can see all quite low p-values. In the path diagram, you'll notice, and I think we'll have an example of this coming up, when you have a regression that is statistically not significant, it'll actually appear as a dotted line instead of a solid line. So just looking right at this path diagram, I don't ever want to tell people to just ignore your parameter estimates table, don't do that. But you can get a lot of information about your results from just the path diagram itself. I can see all 3 regressions are statistically significant. I can see the direction and magnitude of each. I can even see, the residual variance associated with satisfaction. And you'll notice some shading in these boxes. The shading for all these variables that are being predicted by something else represent the R-square for that. So the more shaded in this is, the greater the variability that's being accounted for that variable in the model. Of course, you have no shading for leadership because it's not being predicted by anything. Leadership in this case is something we'd call an exogenous variable. It's not being predicted. Both conflict and satisfaction are called endogenous. They have something predicting them. So for your endogenous variables, you're going to see the shading for your R square. And I should mention, let's say you don't want to see the shading for your R square for anything. Maybe you want to make some other changes. These are highly customizable diagrams. So if I right click and go to customize diagram, I'm not going to walk through this right now, but you can customize the heck out of this diagram to get it looking exactly how you want. And I think this is particularly important for publication, whether you either have your own aesthetic preferences or the journals that you're publishing in have particular requirements. Just know you can get the path diagram looking however it is you want. So for example, we have the R square shading box right here. So if I deselect that and click OK, that shading now has gone away. Now you'll notice for each model you fit, you have this red triangle next to the model itself inside this SEM window where you can request all kinds of different outputs. So for example, the R square for the endogenous variables, if I actually want to see what those values are, corresponding to that shading I just removed, here they are. Or maybe what I want to do instead is pull up the indirect effects. Here, we'll go like that to fill our space. So here's that indirect effect of leadership on satisfaction. Again, the product of these two coefficients. Or we have our total effects right here. So we can see the total effect of leadership on satisfaction, again, 0.673, adding the indirect and direct effects together. Now, if you want to explore this model more visually, if you're used to using JMP, you know about our prediction profiler, which turns your model into an interactive visual. So here's an interactive visual depiction of our model. And here, let me get off the bottom of the screen. So here I have both endogenous variables, satisfaction and conflict, on the y-axis, and I have both leadership and conflict on the x, because both leadership and conflict are predicting at least one thing. We can carefully ignore this graph right here, which is conflict predicting conflict. That line is obviously flat, but I can see, for example, what happens is I change leadership. I can see satisfaction going up and conflict going down, and I can see what the predicted values are. I can also make a change just in conflict and see what its effect solely on satisfaction is. So this is a visual depiction of all of these parameter estimates and what all of our endogenous variable predictions would be given changes in these two variables. So we have fit this mediation model. I hope you've learned along the way a little bit about why we're even doing it, what it can tell us, and also how to implement this in JMP. Now, what I want to do is take a pause, take a sip of water, and see, Kevin, are there any, let's say, brief questions you might be able to answer right now before moving on?
Laura's currently answering. There's two up there now. You could look at the second one to see if you know the answer to that, but I think Laura's getting to it, so I think you're okay.
Okay, let's see. Well, I'll try to answer it now, though. Do the data normalization and missing value handling provided prior to structural equation modeling, also the reliability scores provided? Yeah, so as far as data normalization, that's an option. It's a box you can tick before going into the structural equation modeling platform. So if you want standardized parameter estimates, you can do that. Or I should mention, and we're about to actually talk about this and see it, but just to highlight, if you actually want to get your standardized parameter estimates, here we go. You can switch to them right here. Missing value handling. So you can, there's an option, if you have missing values in your data, you can, oh, actually, I was thinking about, I don't have any missing values, but right here, you can launch the Explore Missing Values platform to explore missing values, but also know that SEM and JMP uses full information maximum likelihood. So it's kind of the state-of-the-art technique for handling missingness. So you can actually have missing values and still create these structural equation models. And then finally, it was the question about reliability scores. So I assume you mean for, let's say, confirmatory factor analysis. You can fit confirmatory factor models in the SEM platform to get those reliability scores if you like. Yeah, all of that's just all kind of a bit beyond the scope of what we're about to cover. I also see a quick question, brief explanation of fit measures. We are headed that way in just a moment. So let me go ahead and get rid of this simple example and get back over to the slides here, where we're now going to talk about expanding our path analysis to structural regression, where we actually have these latent factors. And I've already gone over this a bit, so let's just review very quickly what I mean here. In this particular path model, what we're saying again is that the effect of leadership on satisfaction is mediated through conflict, but you'll see I put asterisks next to leadership, satisfaction, and conflict because now we're treating these as latent factors measured by the multiple survey items that we have for each one. So this is a combination of regression and factor analysis. And structural regression inherently is that. It's just like the path analysis, so the concepts I've been talking about still apply, but we're going to incorporate these latent or unobserved variables. Just a note on terminology, observed variables in this context are often called indicators. So person underscore C is an indicator for the latent conflict factor. And these latent factors, you'll sometimes hear them referred to as constructs. In the academic domain I came from, that is the more common term. So if you hear construct, just know typically that means some theoretical variable that cannot be measured directly. So we're measuring what we can to infer what the value of that theoretical variable would be. And as I mentioned at the outset, and we've just kind of commented on, you'd want to proceed building any kind of structural regression like this with confirmatory factor analysis to validate your measurement model. So that is, you want to make sure that these three items right here do in fact measure conflict and they're not picking up noise from a bunch of other variables as well. So it's typically a whole separate piece of research to develop an instrument, but sometimes out there are well-validated instruments that you can just incorporate into your research. You'll probably still want to confirm that they hold for the particular population from which you've sampled. But that said, you'd be able to move forward with what we are about to do, which is building this structural regression model. Now, I do want to give a quick note on factor loadings for those of us who know something about factor analysis. If not, then hopefully you'll be able to follow this anyways. But if you're familiar with factor analysis, or I should say exploratory factor analysis, but not structural regression, seeing these factor loadings might seem confusing to you. I have a factor loading of exactly 1. I have one of 1.021. And you might say, well, I mean, a factor loading of exactly 1 is extremely unlikely to ever happen. And certainly a factor loading above 1, that's not something I'm used to seeing in exploratory factor analysis. And that's because by default, what we're looking at are unstandardized loadings. Unstandardized loadings can be interpreted like you would a regression slope. So in this case, 1 point increase in the effect of leadership, we believe would lead to a 1.021 increase in the response on this goal survey item right here. Now you'll also notice that for each of these, one of the factors is fixed to 1. That's to actually provide a scale on which we can quantify this latent leadership factor. You know, these latent factors, they have no scale. The scale we assign them is arbitrary. And so what we can do is actually, by definition, say that, well, a 1 point change in leadership leads to a 1 point change in the response to this variable. And in doing so, that gives our leadership factor a scale, and then we can use that scale to calculate the rest of these. Now, this all contrasts with standardized loadings, which if you're used to exploratory factor analysis might look more familiar to you. So here we have standardized loadings right here, and these can actually be interpreted instead as the correlation between the factor and the observed variable. And so they might be a little more interpretable for some of us in that way. So all of these correlations are relatively strong over 0.5, with this loading in particular, 0.629 being the highest, corresponding, of course, to the highest unstandardized loading right here as well. And you'll then see that the variance for this factor or this construct is instead fixed to 1 here in order to give it a scale. And so you can select which one you want at the outset when you're in the SEM platform, and you can just switch between them as I just highlighted with that right-click menu. But I just wanted to say that this was something, honestly, that tripped me up a little bit when I started learning about structural equation modeling, and so I wanted to make sure to highlight it for everybody here. Now then, what we're about to do then is build this structural regression model. We're going to see bigger tables, more parameter estimates, but the same basic ideas apply. So we're going to have our regression coefficients. In this case, it's just regressions of latent factors on other latent factors. We're still going to have the idea of indirect effects and total effects, which will help us actually understand what our model is telling us. So really, it's not a whole lot different than what we were doing before. We're just going to set the model up a little differently and just have to maybe interpret some of these loadings in addition to the other effects that we're seeing. But let's get on over to JMP and do this briefly. And then we should still have time to talk about model fit indices and comparing models and things of that nature. All right. So we're now onto the structural regression. This is the model that we're building right here. We're again saying the effect of leadership on satisfaction is mediated by conflict. We're just in the space of latent factors now. So I'm going to go to Analyze, Multivariate Methods, Structural Equation Models. I'm going to select all of our indicator variables, that is our survey variables. I'm not going to use these averages anymore. You'll notice the standardized latent variables tick box right here, which you could select by default. I'm not going to, but I'll put all of these into our model variables and click OK. Now we have our path diagram where we can specify the model again, but we're not going to create any regressions between any of these indicators. What we want to do is create latent factors out of them. And so here's how you do that. We're going to work entirely inside the to list right here. So I'm going to say support, and I'm going to shift click to interact. These are my leadership items. So down here where it says latent one, I'm going to type leadership and click plus. And now you'll see we've added a leadership factor right here with the loading for the first indicator fixed to 1. So let's do the same then for conflict. I'll click plus and satisfaction and click plus. So I have my 3 latent factors here. Just for those of you who'd want to perform confirmatory factor analysis, one thing I might do here under specification syst is say covary all of my exogenous variables. That would create covariances among our factors. And then when I run the model under the red triangle, you'll find an option called assess measurement model, which will give you all of the CFA statistics that you're looking for. We're not going to do that right now. Instead, what I'm going to do is say, all right, in my theory, leadership predicts satisfaction. Conflict also predicts satisfaction. And then leadership predicts conflict. So now I have our model here. Let me make the screen a little bigger so we can try to fit it all in. Actually, let's use the zoom. I'm going to say maybe down to 0.9. And hopefully that'll all fit right here. All right, so here's our model. Now, I want to point out a couple helpful buttons when working with the diagram right here. These buttons will actually rotate things inside your path diagram automatically. So for example, the big arrow right here will just go from vertical to horizontal. And this one right here will actually rotate manifest variables around their latent factor. So for example, if I click just conflict and click this button, I can go ahead and get those sitting above conflict instead, kind of out of the way. It's a little easier to see the whole model this way. All right, so here's our model. I'm going to call this our mediation model again, and I'll click run. And here we have the outputs that we saw in the slides. So now we have all of the regressions with their magnitude and sign. We can see the statistical significance right here, conflict influencing satisfaction. That's not a statistically significant result. We could actually find that in our regression table right here, p-value of 0.1747. I can go to our red triangle and again request things like the total or indirect effects. Let's just do one of them for the sake of time. I'll pull up the indirect effects and we could find, let me get off the bottom of the screen, the indirect effect of leadership on satisfaction estimated to be 0.275. So 0.275 versus the direct effect, 0.57. So the direct effect is a fair bit stronger than that indirect effect. I would probably spend some time exploring these results a fair bit further. We're already down to just about 12 minutes remaining. So I'm not going to, but again, what we talked about already with respect to the simple path analysis, you could use that same kind of knowledge here as well. So what I want to do now is actually switch over to talking about how we can tell whether a model is good. Now, I probably have theoretical reasons for specifying this particular model, and really you always should. I wouldn't go into structural equation modeling theory agnostic and just start building all kinds of different path diagrams and just seeing which one is good. But even with the theoretical motivation, I want to know how well does this model actually fit my data? And I might even have multiple competing theories that I want to test. So let's finish up by talking about that particular issue and how to go about it. So to understand how to assess model fit, we need to understand a little bit more about how these models work under the hood. I've been kind of saving this for this particular moment, but let's talk about it. So when you're engaged in, path modeling, you have some kind of path diagram depicting your model and the ways in which all these variables are related to one another. That model implies a certain expected covariance structure. So that is which variables actually covary with which other variables. For example, if I had two exogenous variables, that is two variables that are not predicted by any others, I could choose to specify a covariance between them or not. And if I choose not to, what I'm explicitly saying is that there is no covariance or no correlation between these variables, or the covariance should be zero. So the choices I make about how I specify my model and what variables are connected to which other variables implies a certain covariance structure. Now, what happens is the estimation procedure itself tries to estimate parameters values that will match our observed covariances as closely as possible. So in least squares regression, what you're trying to do is create a line through your data or a plane through your data that most closely matches the observed values. You can think about things very roughly similar here, where you instead think about covariances as what you're trying to match instead of individual data points. Again, that's why you can even, I mentioned at the outset, you can build a structural equation model from a covariance matrix. You don't even have to have the raw data, because what you're trying to match are the covariances that you've observed. By, again, fitting parameter estimates that match those covariances as closely as possible. So now to assess how good our model is, we just want to compare the covariances implied by our model to the observed covariances. And in particular, we can even just look at the residuals. So this is one plot you can get out of JMP, which is like a heat map on your covariances and showing how far off your model implied covariances are from the ones you actually observed. And this is a pretty good looking heat map here. I don't see any bright blue or bright red points showing that there are some big discrepancies between implied versus observed covariances. So for example, right here, let's take this second one, light blue. This is representing the difference between the observed and implied covariance of support underscore L and goal underscore L in our model. So our data actually have some covariance, and our model seems to be matching that pretty closely. So hopefully that's a good fit. It's a good idea to inspect these particular diagrams because it can help you assess where there might be misfit in your model, where you're missing the covariances by quite a bit. But there are also a number of measures of fit. I've put together this table for you just for your reference after the fact, and there are plenty of great references online as well, of some different fit measures. They're rough, and I do mean rough, cutoff for what constitutes a, quote, good model, and also some notes on interpreting them. For the sake of time, I don't think we have time to get into any of them. I'll leave it to you to read over this table on your own. And then, of course, if you have any questions about some of this stuff, we always send out follow-up emails after our webinars. I invite you to ask ask more detailed questions about these fit indices if you like. Now, finally, sometimes what you have are two competing theoretical models. So you're not just trying to say, how good is the one model I fit, but I'm going to fit multiple models and compare them. You can do that as well. So with nested model comparison, you can compare any two models where one model is just consisting of a subset of the parameters in the other. I have two diagrams here to help you wrap your mind around this idea of nesting. So we have on the right the model that we already fit. On the left, I'm saying we have a model that is nested inside the model that we fit. And so what I mean by that is that this model on the left is the same as the model on the right, except it has excluded this particular path. What that's really doing under the hood is saying it's implying that the regression between leadership and satisfaction is zero. We're essentially hard coding that into the model and leaving only the indirect path. So this model, model A, is nested inside model B, and you can actually perform a statistical test comparing them. I have an example of the output we're about to produce right here, where we can see that the comparison yields a p-value of 0.0645. So what we might argue is a marginal p-value. I don't want to get into the the weeds of p-values versus other ways of assessing model fit, but we might say, oh, it's borderline whether we might think that this mediation model on the left is better than this other model that's nested with it on the right. But certainly if I had theoretical reason to prefer this model, then I probably would take this as evidence that's at least consistent with the model on the right being better than the model on the left. So let's hop on over and just see how we can pull up fit statistics and also perform these model comparisons. So we're back in our path diagram for our fitted mediation model. You'll notice, let me get rid of the model specification. Now, I pointed this out before, we have our model comparison at the top. You can fit multiple models inside one structural equation model window, and you will get all of the fit statistics displayed right here. So for example, I have a test on the whole model. The null hypothesis for this test is actually that the model fits the data perfectly. So by not rejecting that, we'd say, well, I don't have evidence that this is a particularly bad model that doesn't fit the data. You also have a couple fit indices that are mentioned on that slide. Again, I'll leave it to you to review them, or we can field questions for them after we wrap up here. And under the red triangle, if you need additional fit indices, you'll find that option right here. So here's a big table of many different fit indices you might want to consider, maybe report in your publication. Now, I also mentioned that heat map on the residuals. You can find that under heat maps, and we're talking about the normalized residuals heat map. Again, I don't see any really large residuals here in the dark blue or dark red, but just to show you quickly something that you might find, or an example of what you might find when you clearly have misspecified your model, you're missing something. Let's say that what I'm going to do is in another model, I'm going to assume that leadership and conflict both influence satisfaction. There's no mediation. They just have these independent effects. And I'm not going to put a covariance or anything between them. So I'm going to say that my theory is that leadership and conflict are not correlated at all. That's probably not true. This is probably a bad model. But just for the sake of demonstration, let's run that model and see what we find when we take a look at that heat map for the residuals. And now I can see a couple bright red blocks just screaming at me right here. Now, this is a symmetrical heat map around the diagonal here. So these are telling me the same thing. But if we look at just where this is popping up, this is the covariance of the 4 leadership items with the 3 conflict items. And we have negative residuals here. So my model assumed they were 0. They're clearly not 0. In our data, there's some kind of covariance between these that's not being captured in our model. So that might tell me that if I were to go back up here, what I should do is probably select both of these and add a covariance between them. So that's just one quick example of what you might see when you've clearly misspecified a model. You're missing some kind of covariance or regression. Now, finally, here, I'm going to actually just remove our bad model for now to try to keep the table nice and clean. Let's do a nested model comparison. So let's say that I believe that instead of having the mediation model that we saw, let's see, we're going to get rid of that one. Let's say that I believe this could be a reasonable reality in which leadership doesn't directly impact satisfaction. It only impacts satisfaction through its influence on conflict. So I might say that this is indirect effect only and click run. And so now I could explore, of course, all the parameter estimates and everything for that model, but I now have these 2 models up here, my mediation and indirect only. And I can select them both and just click compare selected models to perform that model comparison test that we saw in the slides right here. And again, I don't have strong statistical evidence that these models fit the data differently, though I might theoretically prefer that mediation model, I think it's highly unlikely, it'd be tough to justify that the only influence of leadership on satisfaction is through conflict. This is really more just for expository purposes here. So it looks like we're at time. I'm just going to point out a couple things that you're going to find inside the resources section of the journal that you're all going to receive. One is a pointer to an add-in that expands some of the capabilities of JMP's SEM platform for the moderation and mediation analysis. So if you, especially, I know this is big in social psychology, moderation, which is essentially like an interaction effect, or moderated mediation, where you have mediation and moderation in the same model. There's an add-in that makes it really easy to do that, including producing simple slope plots, Johnson-Neyman plots, if you're familiar with those. Please do have a look at that. I'm sorry I didn't have a chance to demo it today. We also have an even more in-depth tutorial on SEM in general that I've linked to right here, and that is with the developer of JMP's SEM platform, who I believe has been bombarded with questions, it looks like, in the Q&A throughout here. So Dr. Laura Castro-Shiloh, thank you so much for being here to field all those many questions. And then finally, a link to the documentation on SEM in JMP, because again, we've covered just a fraction of the SEM capabilities here, really just for path analysis and structural regression. You may want to go beyond that. The documentation is a great place to start, but also our team can help you. So you'll all be receiving an email. Once the recording for this is ready, you'll be able to view the recording, download all the materials, and also ask any follow-up questions that we're not able to get to today. But with that said, thank you all for your time and attention, for listening to me talk at you reasonably quickly for a full hour. As usual, I think we have some extra time, so at least Kevin and I'm not sure about Laura, can hang out here and answer all the remaining questions that you have.